In this video, we're going to learn how to break vectors up into their component parts. The problem that we have here is an airplane travels 150 kilometers at an angle of 35.0 degrees north of east. How far north and how far east did the plane travel? In order to do this, we have to first identify the vector that we have. And the vector is a displacement vector. The reason we know it's a displacement vector because it gives a distance, 150 kilometers, and it gives a direction, 35 degrees north of east. When you have a distance with a direction, that's called displacement. So the displacement vector is 155 kilometers, and the direction, which we label theta, is 35.0 degrees, we call north of east. The next thing we want to do, we want to determine our scale that we want to use, and we need to make sure we have a scale so that this 155 kilometers, which in reality we can't draw that actual distance on paper, we have to scale it down so we can draw a vector that fits on our paper and we can use appropriately. The scale that we're going to use right now is going to be 1.00 centimeters, is going to be equivalent to 20.0 kilometers. So this is our scale distance, and that distance 1 centimeter is going to be equivalent to an actual distance of 20.0 kilometers on the surface of the Earth, or in reality. The next thing we want to do is we want to draw our displacement vector with this magnitude and this direction. So we're going to pick a position on our graph paper. I'm going to go ahead and use this position right here. That's going to be our origin. And we want the angle to be 35 degrees. And what we can do, we can imagine a coordinate axis. This is the north-south part of the axis. This is the east-west part of the axis going here. And since the direction is 35 degrees north of east, this direction is east. We want to go 35 degrees north of that, so we want to go this way. We will measure 35 degrees from this line up this way. So we put our protractor on the paper and line it up as precisely as we possibly can. We want to go to 35 degrees this way. This is 30 degrees this point. We put a mark exactly, as precisely and accurately as we can at 35 degrees. We then draw a magnitude of line at this direction, but we need to know what that magnitude or length of that vector is going to be. So we're going to use our scale to convert 155 kilometers to our actual distance. So we're going to do that. We're going to have 155 kilometers, use our scale, 1.00 centimeters over 20.0 kilometers. That way kilometers cancel out. And we should get a distance of 7.75 centimeters. So that's the distance, the scale distance that we're going to actually measure along that angle. We put our ruler up here. We want to measure exactly 7.75 as accurately and precisely as possible. But again, when we do this graphically, there's always some error in our diagram, but we'll make it as accurate and precisely as possible. This is 7.75. That's 7.5, 7.75 is right here, and halfway between there is right about there. So I'm going to make a line there. And remember, this is a vector, so it must be an arrow at that point right there. So this is our displacement vector, which is 155 kilometers, and the angle, which is north of east, is 35.0 degrees. Label everything for that displacement so we know what it is. Now what we want to do is break this vector that's at an angle into its x component, which in this case east component, and its y component, or its north component. The way we do that, we take our ruler and put along the x-axis. We're going to draw a vector due east to represent the east vector, and we're going to estimate as best we can to where that east vector will end up, or that x vector will end up. End up right about here, so we're going to draw that line from here to this point right here. And again, this is going to be a vector. So an arrow there. This is the x component of that vector, so I'm going to call that dx. And then the y component is going to be due north. And the y component and the x component always line tail to tip at right angles to each other. And if we take this x component, we add the y component, we should get the actual vector that we have. So we're going to draw a line from the tip of the x vector all the way up to the tip of the y vector. Again, it's a vector, so we draw an arrow. And this is going to be the y component. Whenever we add the x and y component of a vector, we should get those two the x and y component added up to be that actual vector. We then need to measure the length of this x component. And since we're using this metric ruler, we should be able to go 2 places past the decimal. So this is going to be measured to be about 6.39 if we estimate as accurately as we can. So dx is 6.39 centimeters. We want to convert that to the actual distance. We use our scale, it's going to be 20.0 kilometers over 1.00 centimeters, so that centimeters cancel. And we should end up getting 128 kilometers. We use the correct number of significant digits. We then need to do the same thing with the y component. We're going to measure the length of this y component. This way. 0 mark on the tail. Go to tail to tip. And if we measure to 2 places past the decimal, round it up accurately, this is 4.5. It's just a tad bit past 4.5, so I'm going to call that 4.52. So this y component will be 4.52 centimeters. I then convert that with our scale using 20.0 kilometers per centimeter, so the centimeters cancel. We should end up getting, do the calculation, 90.4 kilometers. So our x component is 128 kilometers, and our y component is 90.4 kilometers. This is the x component of the 155 kilometer vector. This is the y component of that 155 kilometer vector.